Hello, in this lecture we'll find out the area of the green shape. In the drawing we have rectangle ABCD. Inside this rectangle we have this quarter circle and this semicircle. The quarter circle touches the semicircle at this point. We know that side AB of rectangle ABCD equals to 5 units in its length, and our mission is to find out the area of this green shape. So first of all, we will define the center of this semicircle. This point is point O. The center of the quarter circle is here at point C. And the radius of the quarter circle is equals to BC. Repeat again. The radius of the quarter circle is BC. So we define the radius of the quarter circle as x. Therefore, BC equals to x according to our definition. Again, x is the radius of the quarter circle according to our definition. But the radius of the quarter circle is also the diameter of the semicircle. So the diameter of the semicircle equals to x, and therefore the radius must be equal to half of it. Therefore the radius of this semicircle equals to x over 2. So OA is the radius of this semicircle, that is x over 2. And OD is also the radius of this semicircle, that equals to x over 2 units in its length. We know that ABCD is a rectangle, and we also know that opposite sides of a rectangle are equal to each other. So in rectangle ABCD, side AB must be equal to the opposite side DC. But AB equals to 5 units in its length according to what is given in the equation. Therefore DC must be also equal to 5 units. So write it down here. DC equals to 5 units in its length. Here we have an external notch between the semicircle and the quarter circle. That is to say, they touch each other externally at this point. So we will define this point, that is their touching point, as point S. So whenever you have an external notch between two circles or semicircles, you can implement rule 10. So I repeat quickly on rule 10. According to rule 10, if two circles touch each other externally, that is to say, they have an external notch between them, here those two circles touch each other externally at this point, point P. Then the straight line that connects their centers together, here the center of this circle is here at point O. The center of this circle is here at point M. The straight line that connects their centers together is of course the straight line OM. And according to this rule 10, the straight line that connects their centers together, that is actually the straight line OM, passes for their touching point. So the straight line OM passes for their touching point, that is actually point P. Or OPM is one straight line. Again, OPM is one straight line. So you can actually implement rule 10 in our drawing. What because in our drawing we have an external arch between this semicircle and this quarter circle. That is to say, they touch each other externally at this point, point S. Again, this semicircle and this quarter circle have an external arch between them at point S. That is to say, they touch each other externally at point S. So, according to rule 10, the straight line that connects the centers together, point O is the center of this semicircle, point C is the center of this quarter circle, and the straight line that connects the centers together is of course the straight line OC. According to rule 10, the straight line OC must pass through the touching point, that is point S. Again, the straight line OC must pass through point S, that is their touching point. Or OSC is one straight line. Again, according to rule 10, OSC is one straight line. So we connect point C and O together by straight line, and according to rule 10, the straight line OC must pass from point S, that is their touching point. So it is very easy to see from the drawing that indeed the straight line OC that connects their centers together passes from point S, that is their touching point. So what is the definition of line segment OS? Line segment OS starts from point O, that is the center of this semicircle, and ends at point S, that is the point of the semicircle itself. So this is exactly the definition of a radius. Therefore OS is the radius of this semicircle, that is equals to x over 2 units according to our definition. Likewise, what is the definition of line segment CS? Line segment CS starts from point C, that is the center of this quarter circle, and ends at point S, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore CS is the radius of this quarter circle, that is equal to x according to our definition. CS equals to x. And because of the fact that according to rule 10, OSC is one straight line, it means that OC will be equal to OS plus SC. Again, because of the fact that according to rule 10, OSC is one straight line, it means that OC equals to OS plus SC. So I write it down. We actually found out that OC equals to OS plus SC. So OC equals to OS, that is x over 2, plus SC, that is x. So in total, OC equals to x over 2 plus x. So OC in total equals to 3 over 2x, or 1.5x. Actually found out that OC equals to 1.5x units in its length. We know that ABCD is a rectangle, and we know that that all the angles inside any rectangle are right angles. So this angle ADC is a right angle because it is one out of 4 angles inside rectangle ABCD. Therefore it must be equal to 90 degrees in size. So in the next step I will copy the right triangle ODC in a new page, and we will implement the Pythagoras theorem on this right triangle ODC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the formation for Pythagoras theorem. OD equals to x over 2 units in its length, and OC equals to 3 over 2x units in its length. Here we already found out that OC equals to 3 over 2x units in its length. And DC equals to 5 units in its length. So actually, this is the right triangle ODC. This is the right triangle ODC that are coming from the original drawing. According to the Pythagoras theorem, in this right triangle ODC, OC squared, that is the square of the hypotenuse, must be equal to OD squared plus DC squared. So I write it down. OC squared, that is the square of the hypotenuse, must be equal to OD squared plus DC squared. OD is 3 over 2x, therefore OD squared is 3 over 2x squared, that is actually 9 over 4x squared, and it is equals to OD squared. OD is x over 2, therefore OD squared is x over 2 squared, that is actually x squared over 4 plus DC squared. DC equals to 5, therefore DC squared is 5 squared, that is 25. So if we found out that 9/4 times x squared equals to x squared over 4 plus 25. Here we subtract x squared over 4 from this equation, and we get that 9/4 x squared minus 1/4 x squared equals to 8/4 of x squared. So it is equals to 25. 8 over 4 is 2. So in total we get that 2x squared equals to 25. Here we'll divide this equation by 2. And finally we get that x squared equals to 25 over 2. So x squared equals to 25 over 2. Here we take a root out of this equation. And finally we get that x equals to the square root of 25 over 2. The square root of 25 is 5, divided by square root of 2. So in conclusion, I should found out that x squared equals to 25 over 2, and x equals to 5 over square root of 2 units. Our mission is to find out the area of this green shape. What is the area of the green shape? Actually, the area of the green shape is equals to the area of rectangle ABCD minus the area of the semicircle minus the area of the quarter circle. I'll repeat again. The area that we're looking for, that is the area of the green shape, equals in total to the area of rectangle ABCD minus the area of the semicircle minus the area of the quarter circle. The area of rectangle ABCD equals to the width times the length. The width is x, the length is 5, so in total it is 5x. Again, the area of rectangle ABCD is 5x minus the area of the semicircle. The area of this semicircle equals to the area of the circle, that is pi times x over 2 squared divided by 2. So write it down. The area of the semicircle equals to pi times the radius squared, that is x over 2 squared divided by 2, minus the area of this quarter circle. The area of the quarter circle equals to the area of the circle over 4. The area of the circle is pi x squared, and pi x squared over 4 is the area of the quarter circle. So here we have the area of the green shape in total equals to 5x, and we have here minus pi, and here x over 2 squared equals to x squared over 4 over 2 minus pi x squared over 4. So the area of the green shape in total equals to 5x minus, we have here pi x squared over 2 times 4 is 8, so it is pi x squared over 8, and we have here minus pi x squared over 2. Here we multiply both the numerator and the denominator of this expression in order to make a common factor with this expression, so it will be 2 pi x squared over 8. So the area of the green shape in total equals to this expression, it's actually 5x, and we have here minus pi x squared minus 2 pi minus pi x squared over 8 minus 2 pi x squared over 8 equals to minus 3 pi x squared over 8. Okay, so actually found out that the area of the green shape in total equals to 5x minus 3 pi x squared over 8. Okay. So we already found out that x squared equals to 25 over 2, and x equals to 5 over square root of 2 units. So here we'll substitute x by 5 over square root of 2 units, and x squared by 25 over 2. We do it now, we get that the area of the green shape in total equals to 5 times x, and x, we already found out that x equals to 5 over square root of 2. So it is 5 times 5 times square root of 2 minus 3 pi over 8 times x squared, and x squared equals to 25 over 2. Which is 25 over 2. So in total, the area of the green shape equals to 5 times 5 This is 25 divided by square root of 2 minus 3 pi times 25 is 75 pi over 16. I repeat again, we should find out the area of the green shape in total equals to 25 over square root of 2 minus 75 pi over 16 square units, or in terms of numbers, this equals to 2.95 square units. And that is the answer to the question. So, in the next step, I'll summarize the lecture. In this lecture, we found out the area of this green shape. So, in the drawing, we have rectangle ABCD. This is rectangle ABCD. Inside this rectangle, we have this quarter circle and this semicircle. They touch each other externally at this point S. Again, our mission is to find out the area of this green shape. So first of all, we define the center of this semicircle. This point is point O. And we also know that all the angles inside the rectangle are right angles, and therefore this angle ABC equals to 90 degrees in its size. We define the radius of this quarter circle as x. But we know that the opposite sides of a rectangle are equal to each other. So in rectangle ABCD, side BC equals to side AD. But BC equals to x, therefore AD must be also equal to x. So AD equals to x, but AD is also the diameter of the semicircle. If the diameter of the semicircle is x, it means that the radius must be equal to half of it. Therefore, the radius of this semicircle is x over 2. So OA equals to OD, they are both the radii of this semicircle, is equals to x. This is equals to x over 2 units in its length, because of the fact that if the radius is x, if the diameter of the semicircle AD is x, therefore the radius must be equal to x over 2. Okay, so the radius of this semicircle is x over 2. So here we have an external line between this semicircle and this quarter circle. That is to say, they touch each other externally at this point S. Therefore we can implement here rule 10. So I'll repeat quickly on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects their centers together passes for their touching point. So here we have two circles in the drawing, and they have an external line between them at this point P. That is to say, they touch each other externally at this point P. The center of this circle is here at point O. The center of this circle is here at point M. And the straight line that connects their centers together is the straight line OM. And according to this rule 10, the straight line OM must pass for their touching point, that is actually point P. Or OPM is one straight line. According to this rule 10, OPM is one straight line. So we can implement rule 10 in our drawing. Right? Because in our drawing, we have an external line between this semicircle and this quarter circle. That is to say, they touch each other externally at this point S. And whenever we have an external line between two circles, we can implement rule 10. According to rule 10, the straight line that connects their centers together, the center of this semicircle is at point O. The center of this quarter circle is at point C. And the straight line that connects their centers together is, of course, the straight line OC. And according to rule 10, the straight line OC must pass for point S, that is their touching point. Again, the straight line OC must pass for point S, that is their touching point. Or OSC is one straight line. Again, OSC is one straight line. Okay, so again, according to rule 10, OSC, line segment OSC is one straight line. One straight line. If line segment OSC is one straight line, it means that OC will be equal to OS plus SC. Again, if OSC is one straight line, it means that OC will be equal to OS plus SC. Here you can see that OC equals to OS plus SC. But again, OC equals to OS plus SC. So OC in total equals to OS. OS is the radius of this semicircle is equals to x over 2 units according to what we have already found out, plus SC. SC is the radius of this quarter circle that is equals to x according to our definition. So in total, OC equals to x over 2 plus x, that is 3 over 2x. So we found out that OC equals to 3 over 2x or 1.5x. And according to the rule that the opposite sides of a rectangle are equal to each other, we get that in rectangle ABCD, side AB must be equal to the opposite side DC. But AB is 5, therefore DC must be also equal to 5 units in its length. OD is the radius of this semicircle, that is equals to x over 2, and the hypotenuse OC equals to 1.5x or 3 over 2x. The next step, I copied the right triangle ODC in a new page and implemented the Pythagoras theorem on this right triangle ODC. So actually, this is the right triangle ODC that I copied from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ODC is OC, therefore the square of the hypotenuse is OC squared. So OC squared must be equal to OD squared plus DC squared. So OC is 3 over 2x, therefore OC squared is 3 over 2x squared, that is actually 9 over 4x squared, and it equals to OD squared. OD is x over 2, therefore OD squared is x over 2 squared, that is x squared over 4, plus DC squared. DC is 5, therefore DC squared is 5 squared, that is 25. So if we found out that 9 quarters times x squared equals to x squared over 4 plus 25. Here we subtracted x squared over 4 from this equation and found out that 9 quarters x squared minus 1 quarter x squared equals to 8 quarters x squared, and it's equals to 25. 8 over 4 is 2, so total this expression equals to 2x squared, that is 25. Here we divided this equation by 2 and found out that x squared equals to 25 over 2. X squared equals to 25 over 2. Here we took a root out of this equation and found out that x equals to the square root of 25 is 5 over square root of 2. So we found out the values of x squared and x. Our mission is to find out the area of this green shape. The area of the green shape equals to the area of rectangle ABCD minus the area of the semicircle minus the area of the quarter circle. Repeat again. The area of the green shape in total equals to the area of rectangle ABCD minus the area of the semicircle minus the area of the quarter circle. The area of rectangle ABCD equals to the length times the width. The length is 5, the width is x, therefore 5 times x is the area of rectangle ABCD. Because again, the area of rectangle ABCD is 5x. Minus the area of this semicircle. The area of the semicircle equals to the area of the circle divided by 2. The radius of the circle is x over 2, therefore the area of the circle is pi x over 2 squared divided, and if we divide the area of the circle by 2, we get that the area of the semicircle equals to pi times x over 2 squared divided by 2. And again, the area in the semicircle in total equals to pi times the radius squared, that is pi x squared, pi times x over 2 squared divided by 2, minus the area of the quarter circle. The area of the quarter circle equals to the area of the circle over 4. The radius of this circle is x, and therefore the area of the circle is pi x squared. And if we divide the area of the circle by 4, we get the area of this quarter circle. So in total, the area of the quarter circle equals to pi x squared over 4. So the area of the green shape in total equals to 5x. Here we have pi x over 2 squared is x squared over 4 divided by 2 minus pi x squared over 4. So here we have the area of the green shape in total equals to 5x, and we have here pi x squared. In the denominator we have 2 times 4, that is 8. So in total the area of the green shape equals to 5x minus pi x squared over 8 minus 2 pi. Here we multiplied both the numerator and the denominator of this expression by 2 in order to have a common factor with this expression. So after we multiply the numerator and the denominator of this expression by 2, we get that this expression will be equal to 2 pi x squared over 8. So here we have the area of the green shape in total equals to 5x, and we have here minus pi x squared over 8 minus 2 pi x squared over 8 equals to minus 3 pi x squared over 8. And we have already found out that x equals to 5 over square root of 2, and x squared equals to 25 over 2. Here we substituted x by 5 over square root of 2, and x squared by 25 over 2. So in total, the area of the green shape equals to 5 times square root of 2 minus 3 pi over 8 times x squared. And x squared is 25 over 2. So in total, the area of the green shape equals to 5 times 5 is 25. So in total, this expression equals to 25 over square root of 2. And we have 3 pi times 25 is 75 pi. And in the denominator we have 8 times 2, that is 16. So in total, the area of the green shape equals to 25 over square root of 2 minus 25 pi over 16. So in terms of numbers, it is equal to 2.95 square units. Repeat again, after we found out that the area of this green shape equals to 2.95 square units. Okay, thank you very much.